This is SpaceTime Series 21, Episode 88. Coming up on SpaceTime, flares discovered erupting around the Sagittarius A star supermassive black hole. NASA's Dawn mission suddenly comes to an end. And the Hubble Space Telescope back up and running. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have detected flares erupting at the edge of Sagittarius A star, a supermassive black hole lurking at the center of the Milky Way Galaxy. New observations reported in the journal Astronomy and Astrophysics show clumps of gas swirling around at about 30% the speed of light on a circular orbit just outside the black hole's event horizon. It's the first time material has been observed orbiting so close to the event horizon, the point of no return beyond which material falls forever into the black hole's singularity. The authors used the gravity instrument on the European Southern Observatory's VLT, or Very Large Telescope in Chile. Gravity observed flares of infrared radiation coming from the accretion disk around Sagittarius A star. The flares originate from material orbiting close to the black hole's event horizon, making this the most detailed observations ever taken of material orbiting so close to a black hole. While some matter in the accretion disk, the belt of gas orbiting Sagittarius A star at relativistic speeds, can orbit the black hole safely, anything that gets too close is doomed to be pulled beyond the event horizon and in turn disappear from our universe. Relativistic speeds are those which are so great that the effects of Einstein's theory of relativity become significant. In the case of the accretion disk around Sagittarius A star, the gas is moving at roughly 30% the speed of light. The gravity instrument combines the light from all four telescopes of the VLT into a sort of giant optical interferometer to create a virtual supertelescope 130 meters in diameter. Earlier this year, Gravity and Symphony, another instrument on the VLT, allowed the same team to accurately measure the close flyby of the star S2 as it passed through the extreme gravitational field near Sagittarius A star. Those observations provided the first direct evidence of the effects predicted by Einstein's general theory of relativity in such an extreme environment. During S2's close flyby, strong infrared emissions were also observed. It was during those observations the authors were lucky enough to notice the three bright flares around the black hole. This flare emission is caused by extremely highly energetic electrons, originating magnetic interactions in the very hot gas orbiting close to the black hole. It exactly matches the theoretical predictions for hotspots orbiting so close to a black hole of 4.3 million solar masses. You're listening to SpaceTime. I'm Stuart Gary. NASA's Dawn spacecraft has suddenly gone silent, ending its historic mission to study time capsules from the solar system's earliest chapter. The end happened when Dawn missed scheduled communication sessions with NASA's Deep Space Network on Wednesday, October the 31st and Thursday, November the 1st. After the flight team eliminated other possible causes for the missed communications, mission managers concluded the spacecraft has finally run out of hydrazine, the fuel that enables the probe to control its orientation in space, allowing it to point its communications antennas towards the Earth and to position its solar panels towards the Sun. The Dawn spacecraft was launched 11 years ago to visit the frozen worlds of Vesta and Ceres, the two largest objects in the main asteroid belt between Mars and Jupiter. The images and data that Dawn collected from both Vesta and Ceres are critical to understanding the history and evolution of the solar system. The Dawn spacecraft was launched back in September 2007 on a 7 billion kilometre mission to explore Vesta and Ceres. These two worlds are on opposite sides of the snow line, the distance from the Sun, where it's cold enough for volatile compounds such as water, ammonia, methane, carbon dioxide, and carbon monoxide to condense into solid ice grains. The 1,218 kilogram spacecraft achieved orbit insertion around the asteroid Vesta in July 2011. Vesta is the brightest asteroid visible from Earth, and it contains some 9% of the total mass of the asteroid belt. The 525-kilometre wide world has a differentiated internal structure, typical of terrestrial planets, with a metallic nickel-iron core surrounded by a rocky mantle. After some 14 months of surveys, Dawn left Vesta and travelled to its second target, the dwarf planet Ceres, arriving in March 2015. Ceres has a diameter of 945 kilometres, making it the largest object in the main asteroid belt, containing a third of the belt's total mass. Ceres appears to be differentiated into a rocky core and an icy mantle, and there are indications that it may have a remnant internal ocean of liquid water under its icy crust. If that's the case, the mystery is what heat source keeps it liquid. Ceres' surface is a mixture of water ice and various hydrated minerals such as carbonates and clays. Dawn Chief Engineer and Mission Director Mark Raymond from NASA's Jet Propulsion Laboratory in Pasadena, California, says the historic mission has changed astronomy's understanding of planetary science. He says Dawn was the first spacecraft to visit a dwarf planet, the first to go into orbit around 2 destinations beyond the Earth, and one of the first to use an ion propulsion system.
When you work on a mission this long, it feels like a part of you. I've been a space enthusiast since I was 4 years old. Getting to work on a mission like this, it's a dream come true. To me, Dawn is truly Earth's first interplanetary spaceship. No other spacecraft has gone to a distant body, gone into orbit around it, maneuvered there, then broken out of orbit, traveled elsewhere in the solar system to another alien world, and gone into orbit around it. And it does that with ion propulsion, which I first heard of in a Star Trek episode. We've turned ion propulsion from science fiction into science fact.
The data from Dawn that was beamed back to Earth enabled scientists to compare the two planet-like worlds, which have evolved very differently. Among its accomplishments, Dawn showed just how important location was to the way objects in the early solar system formed and evolved. Dawn also reinforced the idea that dwarf planets could have oceans over a significant part of their history, and potentially still do. Dawn's principal investigator, Carol Raymond, also from JPL, says in many ways Dawn's legacy is just beginning. Dawn's data sets will be deeply mined by scientists, working on how planets grow and differentiate, and when and where life could have formed in our solar system. Ceres and Vesta are important to the study of distant planetary systems too, as they provide a glimpse into the conditions that may exist around young stars.
The Dawn mission really is a journey back to the beginning of the solar system, and that's why we call it Dawn. We chose 2 time capsules from the beginning of the solar system, Vesta and Ceres, which are the most massive and largest bodies in the main asteroid belt. They both formed very early when the solar system was forming out of the protoplanetary disk, and yet they ended up in these 2 very different states. Vesta is a dry, rocky body that looks a lot like our moon, whereas Ceres had a lot of water, and it looks much more like the icy moons of the outer solar system.
And it seems like what determined their eventual fate was the location where they started. And we now believe that Ceres formed much farther from the sun than it is now.
When Dawn found the bright material on Ceres, what we saw was completely mind-blowing. It was made of sodium carbonate. Sodium carbonate is not common in the solar system, but we see it coming out of the plumes of Enceladus. We see it in lakes on Earth, and here it was on the surface of Ceres.
Dawn went silent while in orbit around the dwarf planet Ceres, where it will now remain.
Dawn will become this inert celestial monument in orbit around the dwarf planet that it unveiled.
Dawn will remain in orbit around Ceres for at least the next 20 years, and engineers have more than 99% confidence that that orbit will last for at least half a century.
Dawn serves as a lasting reminder that the passion for bold adventures and our noble aspirations to reach out into the cosmos take us far, far beyond the confines of our humble home here on planet Earth.
You're listening to SpaceTime. I'm Stuart Gary. NASA's Hubble Space Telescope is back up and running normally after going into protective safe mode 3 weeks ago. The safe mode was triggered when a gyroscope needed for aiming the telescope suddenly failed. The problem persisted when a reserve gyro designed to replace it failed to perform as expected. Safe mode places Hubble's scientific instruments in a stable and safe position. It points the telescope's lens away from the Sun and its solar arrays towards the Sun for maximum energy. Hubble uses 3 gyroscopes at any one time to measure the speed at which the spacecraft's turning and then to help it lock on new targets. The Earth-orbiting Space Telescope has 6 gyros, 3 for operations and 3 in reserve. The backup gyro, which was actuated, was the last of the 3 in reserve. Gyroscopes are a bit like spinning tops. They're designed to keep a vehicle stable regardless of movement around it. In the case of Hubble, a wheel inside each gyro spins at a constant rate of 19,200 revolutions per minute. This wheel is mounted in a sealed cylinder called a float, which is suspended in a thick fluid. Electricity is carried to the motor by thin wires the diameter of a human hair, which are immersed in the fluid. Sensors within the gyro then detect very small movements of the axis of the wheel and then communicate this information to Hubble's central computer. Each gyro has 2 modes, high and low. High mode is a course mode, used to measure large rotation rates when the telescope's turning across the sky from one target to another. Low mode is a more precision mode. It's used to measure fine rotations when the spacecraft locks onto a target and then needs to stay very still as scientific observations are taken. Okay, so what happened? When the primary gyroscope failed and the last of the backups were switched online, mission managers suddenly began receiving anomalous readings, measuring rotation rates tens of times higher than what was really happening. And while all that could be compensated for during high mode, it proved impossible for the computers to deal with in low high-precision mode. If the issue couldn't be resolved, mission managers would be forced to switch the telescope into a single gyro mode, which would have affected the quality of the science being carried out. In an attempt to resolve the problem, mission managers at the Space Science Institute in Baltimore, Maryland, executed a running restart of the replacement gyro, turning it off for just a second and then restarting it before the wheel spun down. The intention was to clear any faults that may have occurred during the original startup of the gyro. After all, the gyro hadn't been activated since it was installed 7.5 years ago on the very last Space Shuttle servicing mission. Unfortunately, the running restart didn't improve things, and so mission managers tried a series of spacecraft maneuvers or turns in opposite directions to attempt to clear any blockage that may have caused the float to be off-center and produce the exceedingly high rates. During each maneuver, the gyro was switched from high mode to low mode to dislodge any blockage that may have accumulated around the float. It's the NASA equivalent of giving things a good shake. And the good news is, this resulted in a significant reduction in the high rates, allowing rates to be measured in low mode for brief periods of time. Additional maneuvers and gyro mode switches were then performed, which appear to have finally brought the replacement gyro back into normal operations, in the process allowing precision science operations with Hubble to resume as normal. I'm Stuart Gary. You're listening to SpaceTime. Stratolaunch says it'll start flying rockets into space from 2020. The Seattle-Washington-based company is a joint venture between Microsoft co-founder Paul Allen and Scaled Composites boss Burt Rutan, who had previously developed and built Spaceship One, the X-Prize winner, which became the first privately manned spacecraft to reach space twice within the space of 2 weeks. Rutan's also behind the development of the Virgin Galactic space tourism venture using Spaceship Two and the White Knight 2 mothership. The centerpiece of the Stratolaunch system is the new giant twin-fuselage 6-engine mothership, considered the largest aircraft ever built. Constructed by Scaled Composites, the carrier plane is powered by 6 Pratt & Whitney PW4000 jet engines, sourced from 2 Boeing 747-400 airliners. In May last year, the first Stratolaunch carrier aircraft was towed out of the Stratolaunch Mojave building to start ground testing. Eventually, it'll carry spacecraft between its twin fuselages, taking off horizontally from conventional aircraft runways and climbing to altitudes of around 50,000 feet. The The mothership will then release its spacecraft, which will freefall for several seconds before igniting its own onboard engines and rocketing into space. It's the same principle as used by Burt Rutan in both his original Spaceship One X Prize winner and also Virgin Galactic's Spaceship Two program. In fact, the Stratolauncher is very much just a scaled-up version of Spaceship Two's White Knight 2 mothership. As well as utilising the existing Orbital Sciences air-launched Pegasus rocket, which carries a 370kg payload, Stratolaunch is also developing its own new medium-class air-launch vehicle, optimised to carry 3,400kg and expected to be ready for flight by 2022. An even larger 3-core version of the medium-class air-launch vehicle capable of carrying up to 6,000kg and a reusable spaceplane capable of returning payloads to the ground are also being planned. And that spaceplane will most likely be Sierra Nevada's Dream Chaser. Queensland orbital rocket builder Gilmour Space Technologies have secured $19 million in seed funding to launch their next-generation hybrid rockets into space. The funding will allow the Gold Coast company to scale up and launch its first commercial hybrid orbital Ares 3-stage rocket in 2020. The Series B funding round was led by top-tier venture capital firms in Australia, Main Sequence Ventures, which manages the CSIRO's Innovations Fund, and Blackbird Ventures, which led Gilmour Space's $5 million Series A funding round back in May 2017. Other investors include US-based 500 startups, which increased its stake from the Series A round, as well as the new venture capital family office and private investors. Company's founder and CEO Adam Gilmour says the small satellite revolution is gaining momentum globally, with thousands of small satellites slated for launch into low Earth orbit over the next 5 years. However, these new players are being challenged by high launch costs and limited launch opportunities. To address this bottleneck, Gilmour Space is developing a new breed of hybrid rockets that will offer low Earth orbit launches to small satellite customers. The company plans to launch the Ares 100 in 2020. It's a 3-stage commercial launch vehicle capable of carrying 100kg into low Earth orbit. That'll be followed by the Ares 400 in 2021, a clustered engine vehicle for payloads of up to 400kg. Although space investments are comparatively new to investors in the Asia-Pacific region, they are starting to take notice. Since January, Gilmour's achieved a number of key milestones. It's completed a series of ground tests on its orbital-class hybrid rocket engine, generating a record 80 kilonewtons or 18,000 pounds of thrust. It signed a Space Act agreement with NASA, the first private Australian company to do so, and it's preparing for a suborbital test flight in a few months' time. Gilmour says his trajectory analysis shows Queensland's far north coast would be the best location for an orbital launch facility. That's because the closer you are to the equator, the more assist the launch vehicle gets from Earth's rotation. In fact, back in the 1980s, proposals were mooted for a spaceport on Cape York Peninsula, but that idea died following opposition from the region's traditional Aboriginal owners. I'm Stuart Gary. You're listening to SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Secret intelligence reports given to Australian national security officials have alleged Chinese government cyber espionage agents have been using China's telecommunications giant Huawei to hack into foreign computer networks. Several governments have already locked Huawei and another Chinese company, ZTE, out of any involvement in sensitive projects, including the development of Australia's 5G network, because of cybersecurity concerns. Huawei have constantly denied any involvement in espionage, including the alleged cyber theft of data from the African Union's Ethiopian headquarters. Meanwhile, in a separate case last month, the United States government have charged Chinese cyber spies with commercial espionage after they tried to steal technical secrets on commercial jet engine technology. Beijing has also targeted Australian and American universities, the Australian Reserve Bank, as well as Taiwan, Brunei, Myanmar, and Vietnamese government agencies. US intelligence agents tracked the attacks to a specific IP address in a 12-story office building on the edge of Shanghai. That office building is used by the People's Liberation Army Cyber Espionage Unit 61398. And the same Chinese espionage group has been responsible for stealing hundreds of terabytes of data from at least 141 US government organizations. And it doesn't end there. Another Chinese government hacking group known as Cloudhopper has been stealing intellectual property for years from Western companies as part of what US Homeland Security describes as an escalating campaign. The latest Chinese hacking thefts come just days after it was revealed that Iranian government hackers undertook a cyber attack and extortion attempt against Western Australian shipbuilder Austral. The defence contractor builds naval frigates and patrol boats for the Australian Navy, as well as combat vessels for the United States and Oman. Austral insists neither commercially sensitive documents nor any material affecting national security was compromised in the attack. Internet speeds could soon be 100 times faster thanks to groundbreaking new technology which harnesses twisted light beams to carry more data and process it faster. While broadband fibre optics carry information at the speed of light anyway, the slowdowns occur because of the way the data is encoded at one end and then processed at the other. Now, a report in the journal Nature Communications claims a world-first nanophotonic device can encode more data and process it much faster than conventional fibre optics by using a special form of twisted light. Current state-of-the-art fibre optics communications, like those used in Australia's national broadband network, only use a fraction of the light's actual capacity by carrying data on the colour spectrum. New broadband technologies under development use the oscillation or shape of the light waves to encode data, increasing bandwidth by also making use of light outside the optical range. The data is then transmitted by light waves that have been twisted into a spiral to increase their capacity even further, through a process known as light in a state of orbital angular momentum, or OAM. Well, as you may have noticed on the SpaceTime blog, social media's been abuzz this week after NASA detected a massive, almost perfectly rectangular-looking iceberg calmly floating in the waters off the northern Antarctic peninsula. The strange berg was spotted as part of Operation Icebridge, NASA's longest-running aerial survey of polar ice. During the survey, designed to assess changes in the ice height at several glaciers draining into the Larsen A, B and C embayments, Icebridge scientists spotted a very sharp-angled tabular iceberg floating amongst the sea ice just off the Larsen C ice shelf. The rectangular iceberg appears to have been freshly carved off Larsen C, which, as you may recall in July last year, released the massive A68 iceberg, a chunk of ice about the size of the state of Delaware. Well, they're already regarded as one of the most intelligent species on the planet. Now, New Caledonian Crows have shown they're not only able to fashion simple tools to help them get food, but it seems they can also build their own tools from scratch out of separate independent parts that wouldn't normally go together. The remarkable findings, published in the journal Scientific Reports, describes how these clever birds create long-reaching tools out of short combinable parts. The assemblage of different components into novel, functional and maneuverable tools has until now only been observed in humans and higher apes. In fact, anthropologists regard early human compound tool manufacture as a significant step in brain evolution. When you think about it, kids take several years before they're able to create novel tools, probably because it requires anticipating the properties of yet unseen and consequently still being imagined objects. This sort of anticipation or planning usually is interpreted as involving creative mental modelling and executive functions. The study demonstrates that the species of crow possesses highly flexible abilities that allow them to solve complex problems involving the anticipation of properties of objects they've never seen. The New Caledonia Crows are of the same species as the famous bird Betty, who became famous back in 2002 as the first animal shown to be able to create a hooked tool by bending a pliable material. There's been a security data breach at the Perth Mint, which has hit thousands of customers. The Mint is the Australian government's official gold and silver bullion producer. While none of the Mint's own data systems were breached, it's understood the systems of a third-party technology provider were affected, impacting customers who had bought or sold precious metals through a supposedly secure online trading platform. With the details, we're joined by Alex Zaharov-Reut from IT Wire.
They came out earlier in September to state that there were 13 people that had been affected by this, and then they had to come out a few weeks later to say that actually there was 3,200 people that were affected. And they say that, look, it wasn't their systems, it was a third-party provider of some sort that who was hacked, and the Perth Mint is saying that they've contacted all of the affected people and they're giving them advice on what to do about the data being breached. But it really does make you wonder whether, if you're going to be shopping online, whether you should be using any of your standard accounts. You know, you should be getting one of these disposable credit cards or have a different bank account where there's only a certain amount of money in that account. And so that if that information is breached, it's a much less important account than your main bank accounts and your main, usernames and passwords. And I guess we just have to be street savvy. I mean, the question about hacking is it's not if, but when. And if that's the case, and you're buying gold and silver and other valuable, metals with your own bank details and credit card details, well, you have to decide, am I going to risk it, or am I going to get some sort of disposable card or, secondary account, or do something so that if it is breached, it's not your main data that's being affected.
And that report by Alex Sahara-Vroit from IT Wire. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favorite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.